to start the loading and performance section of your Part 107. This section is pretty simple, common sense. We're going to be learning a few new key terms, nothing difficult. So each drone, comes with a manual, and the manual is specific to each individual drone. There's not really a standardized form or operating system for these drones. And then we need to check the weather conditions, and prior to flying, consider what kind of effects that the weather is going to have on the performance of our drone. So pretty much just know the drone, know its capabilities, what weight it can handle, things like that, and then check the forecast. So we're going to go back and kind of recap the speed and altitude limitations, how fast you're going, the heights you can fly your drone. This is something that will definitely be on the test, so we're kind of going to keep pounding it in. But your drone, to be a SUAS, a small unmanned aerial system, it cannot be flown faster than 87 knots or 100 miles per hour. Just remember, 87 knots, 100 miles an hour. And then your drone cannot fly more than 400 foot above ground level, unless you are flying over a structure. And then you can fly an additional 400 foot over top of that structure. So 87 knots, 100 mile an hour is max speed. 400 foot above ground level or 400 foot above a structure is the maximum height. And some more terminology we need to kind of remember is your air flight controls, which is your pitch, your yaw, and the roll. So your pitch is the up and down. So you're flying this way, you can go up or down. That's the pitch of your aircraft. The yaw is if you're flying and you want to turn left or you want to turn right. That's the yaw for the aircraft. And then the roll is just what it says. It's rolling the whole aircraft left or right. So pitch, yaw, and roll. So if you're flying the drone, and on all drones, it's going to give on your controller your altitude, the distance you are away from the controller, and it's going to give your speed. If something happens, it goes out, and you want to know your speed, you use what is called dead reckoning. So you fly on your drone, and you know that it is 200 feet between these 2 points. When your drone passes this first point, you start counting. 1, 2, 3. And then however many seconds it takes it to get to the second point is how fast you're flying, your mile per hour. Alright, so if you're loading your drone, you could be putting packaging on it. For you guys, for linemen, you might be tying rope to it, or P-line to pull line across the river or something. You need to make sure that you're in compliance with the weight and balance limits of your specific drone. And whatever weight you add, it shouldn't adversely affect, negatively affect the center of gravity. Say your drone's here and you have your weight right in the center, it's going to set level. You put it on the front, it's going to make it front heavy. Put it on the back, common sense stuff. So it needs to be loaded to, where the center of gravity, it's perfect. It's right in the center. And then also when they're talking about loading, they also mean like the camera system and stuff like that. That's loading your drone. So, and we got to use common sense too. The main thing, if you use common sense, you're going to be perfectly fine flying this, doing your operations. But check the weather. If if the wind's kind of up or it's raining or whatever, and with that extra weight, it's going to negatively affect the performance of your drone. We just don't need to do it that day or at that moment. And some other things to remember, if you have a loaded drone, battery life's not going to last as long because you're pulling more on it. The drone's having to work harder. It's going to reduce your rate of climb. It's not going to climb as fast. Maneuverability is not going to be as good. You can't fly as high. Or just simple things like that. Some of this stuff might be on the test, but it's something we're going to go over. So, and prior to doing your mission or your job or whatever you want to call it, test it out and make sure that your drone, if as long as you're in the recommendations for your drone, go ahead and test it out and make sure that your drone is actually capable of doing the job. So I think we're going to meet in person maybe in the next couple of weeks, and you all are going to get to fly the drones. And when we do that, we're going to talk about things. I can explain it better in person. Is load factor and what it does to your drone if you're loaded, and you go to an angle. It's going to pull more G's, G-force on your drone, and it's going to decrease the performance of your drone. But we're going to talk about that in person. And then stalls, what causes the drone to stall, your chord line, your angle of attack, the critical angle of attack. We're going to talk about all that in person, and I'll try to break it down for you, and hopefully we can all understand it and grasp it then. So like I said, this section was kind of short. Just a few new key terms you need to remember, a few more numbers, nothing extravagant, nothing overwhelming. If y'all got any questions, text, call, email me, and we'll get it done. See you.